Today we're going to learn about mutually exclusive and overlapping events. So first we need our definition of what it means to be mutually exclusive. And so here we have our definition right here. This is our definition. And it kind of explains what mutually exclusive events are. So two events are mutually exclusive if they cannot both occur in the same trial. Okay, so they cannot both occur in the same trial of an experiment. So an example of this would be if you want to flip a coin, it cannot land up on heads and tails at the same time. Therefore, the events are mutually exclusive. So let's look at what it would look like in terms of our notations. So for our notation, our mutually exclusive events, if event A and B are mutually exclusive, then the probability of A or B is the same as finding the probability of A plus the probability of B. So remember that in mathematical terms, an OR statement means add. So let's look at an example. So a number dodecahedron. So a dodecahedron is just a numbered cube that has 12 sides, and they are numbered 1 through 12, just like a regular dice would be 1 through 6. I want to find the probability that you roll the cube and it's the result of an even number or a 7. Now these two are mutually exclusive events because you cannot have it be an even number and 7 at the same time. So this little Venn diagram, what we want to do is write in some of the values and see where they overlap. So for example, event B is just the probability of getting a 7, whereas event A is anything that would be an even number. For example, 2, 4, 6, all of our even numbers that are 1 through 12. 10, and then 12. Okay. And all of our other odds would be in the sample space. So 7 is the only one that is in event B. The rest of the sample has events 1, 3, 5, right, everything else, 9, and 11. So let's calculate the probability of A. And that's the probability that we will have an even number. And so as we can see, we have a total of 12 sides. And so our denominator, the total number, is going to be 12. And if I count up the number of items in event A, or the favorable outcomes, there are 6 different options for even numbers. So when I simplify, I get the probability of rolling an even number is 1/2. Now I want to calculate the probability of getting a 7. Well, there's only one of the 12 options to get a 7. So let's look then at calculating what is the probability of getting A or B. Now the total number of options in the sample, right? The total number of options in the sample is still 12, all right? Now, the probability of getting something that's even, there are 6. There is only one possibility of getting a 7. And so total, there are 7 options in events A or B. So the probability of A or B is the 7 options I have together with those events out of the 12. Now this would be calculating the probability of events A or B together, but we can also calculate the probability of A plus B and get the same result. For example, I can use this information right here and say that the probability of A is 1/2, right, plus the probability of B, which is 1/12. And if I get a common denominator and add those two together, I get 7/12 as my probability of event A or B. So the probability of A plus the probability of B is equal to the probability of A or B. And this is the two options you have of trying to calculate with mutually exclusive. Now, the other type of event that we want to take a look at is overlapping events. So two events are overlapping, and we call these inclusive events if they have one or more outcomes in common. Okay. So now this rule is, we call it the addition rule. Right. And so we say that the probability of A or B when we are having overlapping events is not just the probability of A plus the probability of B, but we need to subtract off the area of where they have an overlap. So let's look at a couple of examples of overlapping events. So let's look at the dodecahedron again. And so now what I want to do is I want to figure out, again, it's an even number or a number greater than 7. So now it's not just 7, but a number greater than 7. So again, let's write in what values we have. So in event A, we have 2, we have 4 and 6. In B, we have a bunch of other numbers. We have just odds, I guess. So that would be 9 and 11. Those are numbers greater than 7. But in this middle space here, we have the numbers that are greater than 7, but are also even. And that would be our 8, our 10, and our 12. And so any other numbers that are not either even or greater than 7 are going to be on the outside again in the sample. So 1s, the number 3, the number 5, and the number 7. So 7 is now on the outside in the sample because this says I want something greater than 7, which does not include 7. So now when I calculate the probability of A, I still have 1, 2, 3, 4, 5, 6 of the 12 still in A that are possible. Okay. When I calculate B, now probability of event B has 5 options. And so when I calculate this intersection, I definitely need to know what this intersection area, how many are in there. And that's the probability of A and B. So now I have 3 of the 12 in A and B. So I want to use this little Venn diagram to figure out what is the probability of A or B. And so again, if I add all those up, I have 1, 2, 3, 4, 5, 6, 7, 8 of the 12 possibilities for A or B, and that's going to simplify down to 2/3. So now let's use all of these pieces to figure out what the probability of the actual event is that I'm being asked about. So again, the probability of A, the probability of A, and I can use the ones that here, these fractions that are unsimplified, all right, so I don't have to worry about common denominators, all right. So I'm going to use these ones right here that are unsimplified. And so the probability of A is 6 out of 12. The probability of B is 5 out of 12. Let's erase that. And then the probability of A and B is 3, if it wants to write, out of 12. So it's a new program and it's having issues. So if I use all these pieces of information and I start doing my math, what am I going to get? I'm going to get 6, I'm going to think about just the numerators, out of 12, plus 5 out of 12. Then I need to subtract off 3 of the 12. And so when I subtract that, I'm going to end up with 11 minus 3, which is the 8 out of 12. And that's the same as 2/3. So we can see how the rule actually is going to apply when we're doing our probabilities. All right, so those are some mutually exclusive and overlapping events. But we want to look at some other types of events that utilize those concepts. And one of them is finding probabilities from a two-way table. Okay. So what we want to do is we want to use this Venn diagram, or this two-way table, to find out the probability that we have a senior or a girl. And now this is obviously going to be an overlapping sort of scenario because it is possible to be a senior girl. So what we want to do is first you need to look at how are we going to use a two-way table. So the way a two-way table works is that you can use information going this direction and information going this direction. And so if I want to know how many girls total there are in the entire school, that is going to end up being 412 out of the 808. And the number of seniors that are in the school is 202 out of 808. But there's an overlap right here of where you are a senior and a girl. And so that's the number 108. So we're going to use that in trying to calculate probability. So if I think about the options, so the probability, if I can get this to work, probability of being a senior, right? That right there, the probability of being a senior, that is the 202 out of the 808. The probability of being a girl, well, that is the 412 out of 808. And so if I added those two together, I would also have to subtract off the probability that you are both a senior and a girl. And that right there is the 108 out of 808. And so now if I think about doing all of that subtraction and simplifying my fractions, right, all of that together, move it on up here, this is going to be the value 253 out of 404. And again, that is a simplified fraction if I add the probability of senior and a girl and subtract off both. So let's look at one more option, or one more problem here. And again, this is the type of two-way diagram, and I want to know the probability that I have a headache and I took no medicine. So again, if I want to know the total number of headaches, right, there are 27 people who have headaches out of the 100. Right? There are 40 of those people who took no medicine out of the 100. And then I have this overlap right here that there are 15 people who took no medicine and have a headache. So again, the probability that I have a headache all right, that's 27 out of 100. plus the probability of no meds. Right, so I'm going to simplify that down to no meds. And that was 40 out of 100. And then I need to subtract off both. And again, that was 15 out of 100. And so if I do all those calculations and simplify, right over here, the probability of the event that I'm asked about, I should get 13 out of 25.